Okay, this session I'm working on SimpleArchiver. Something I noticed while doing backups with this, if there's a lot of files to be archived, maybe like about 1 million or so, there's a lot of files, then it's slow getting started. So this session I'm adding like stats that print at the beginning of archival. When you create an archive, it does some pre-processing of the input files to know exactly what to archive. So, this session I'm just going to be adding like how much percentage is done and how long the pre-processing steps took and stuff like that. So to keep track of time, I use a time function specified in time.h header. Just looking up the man page for it so I know exactly how to use it. So this time function returns the number of seconds since epoch or whatever. So I just compare two different calls of this to get the number of seconds elapsed. I try to enclose it in curly braces so that the time variables don't last for too long. But in the end, I removed the curly braces because there's stuff here that needs to be available later on in the code. So because of those curly braces, like I said before, there's stuff inside those curly braces that need to be available, so I have to remove those enclosing curly braces. Otherwise, the scope of the stuff enclosed in there would end and it wouldn't be available later. So I'm putting a build of this in temp so that I could access this from any user. And I need to test this against some large amount of files so that I can actually test the changes I'm adding, see the progress. So I log in as root so I can access the snapshot I have in my files. And what I'm doing is taking an archive of that snapshot of my files, a BTRFS snapshot. Long story short, I have on-site backups and remote backups. And I'm using a SimpleArchiver to archive the local backup of files. And since there's a lot of files in root, it does take a while to resolve. And this is how I test the changes I made. And then I see it took 11 seconds to get through one step. So for now, this small change I'm committing as a separate commit. Now there's another place where it may take a long time to get through before actually archiving. This is checking all the files and symlinks that are in the specified path. So I'm checking if there's a count for the working files data structure, and there is. So I'm going to be using that to print a percentage progress during a step. So because this function is called from different places, I have to ensure that the data passed to it is consistent in every call. Which makes sense since I want to keep track of that kind of thing no matter where it's being called from. This pointer array works because every pointer is the same size on a single computer, or per the system you're on. As long as your pointers don't go to another computer, the pointers are all the same size, which usually is okay even if, well, the pointers are meaningless to another computer, to be honest, because it's local to the computer itself. So I could have malloc size of void pointer times the number of pointers I need. And then I could just assign a pointer to one of those slots in the array. It turns out I also need to store a pointer to a time t type variable so that it can have some sense of time by comparing the time passed to it and the current time. The way I set up the stats is that if the 5 seconds have passed, then it will print the percentage instead of printing like every 10% or something. So naturally, if it takes a long time, it will print stats about how much progress has been made. Here's an error, but I fixed it later, using start time for two different things. The right thing to do is to replace it with a new variable. I fixed that later in the session. In other places the function is called, there is only one start time. How the function is called is an iterator function is called on a set or a list. I don't remember if it's a hash map or if it's a list. I think it's a hash map. But long story short, for every file in that structure, it will call that function on it. That's what the helper function basically does. And that is why I need to send it a pointer to something that persists between function calls, because that function is being called once per item in the data structure. And here is where I make the constant 5 seconds. The PRIU64 is a macro that resolves to a string literal. If you look at the documentation for it, it's basically what, if you need to print a U in 64T, that's the literal you need to give to printf to print it properly. So I realize I also need to send the actual size of the data structure, because from within the function call, there's no other way to get the size of the data structure. And here's where I calculate the percentage. 100 times the current count divided by the total count. Because it's an integer, it truncates anything that would be a decimal value, or a less than 0, or less than 1 value, that is. Like, instead of being 13.5%, it'll be strictly a whole number, 13%. By multiplying by 100 first, it ensures that the whole number will be there between 100 and 0, since the range of the count divided by the total size is between 0 and 1. And this problem is just forgetting to dereference a pointer. Start time is a pointer. And I have to work on the value that's being pointed to. Switching back to root again to test it again. And now there's a percentage being posted every 5 seconds. That took longer than 2 seconds, so I know that there's a problem with setting the variable there. So I shouldn't have reused start time. This is what I talked about earlier. I have to create a new variable instead of reusing it. Note that when I'm recording with asciinema, I set the idle time to 3 seconds, so naturally if the screen is idle for more than 3 seconds, asciinema will truncate that duration to 3. So you will see a 3-second pause, but in reality it may have been longer than that. Just some testing to ensure that the files are still being compressed and archived and decompressed and extracted properly. And a git commit for these changes. Updating the changelog, just noting that these changes just keep track of steps taken before the archival starts. Running it again to see what else, if it needs more testing, or just using the snapshot of home this time because root went by a little bit faster. I guess the cache warmed up for root. So here there's a lot of stuff going on before I even reached the part I added changes for. So I need to add stuff here before everything else. Turns out it is in parser. So it's tricky here. I don't have a size of files, total number of files, because I'm fetching up to a total number of files at this stage. So instead, I set it up to every 5 seconds, print the number of files added to a data structure. Here I'm adding the constant for the number of seconds to wait, which is still 5. In C, there's no constant expression stuff like C++ does. So instead, one uses the define macro. So the preprocessor handles it and puts it as literal in your code when it gets compiled. Testing it again now. Notice that 5 seconds have passed at least, and nothing got printed. Turns out there are multiple loops in that part of the code. So I need to add the same code to the beginning of every loop within that block, which is okay because checking against the time, it's never going to do it faster than a 5-second interval by the way it's been written. So for the loops that aren't going through a C string, I add the blocks of code that check against the interval and prints current status. And as you can see, it's now working. Over 1 million paths in my home directory, apparently. And committing these changes in this point in the session. I think I'm checking if working files has a lot of stuff in it. The data structure, that is. I need to pass the total number of files, and I need to pass a variable for it to keep track of the current number of files processed. And now I'm setting up the pointers to use the pointers set passed to it. Now there's a mismatch here. At array index 2 is supposed to be a size t, and it's not guaranteed to be a uint64 t. So I have to add another variable to the array and check against both when I need to use it. Now I can just check if either count is null. If it's not null, then I use it, and if it is null, I don't use it. Pretty simple check, actually. Here I realize I need to add a time variable to keep track of time between function calls. Like I said before, when it's iterating through these files, it has to have some state that's being persistent, which is done by passing as a pointer in this data array. So there is one place in the code where I don't account for the 6th item in the pointer array. I fixed that later in the session, I think. And now for building and testing. So it looks like it's working. I just forgot the percent sign. And for some reason I switched to a uint64. Thinking about it, it might have been better to just use integer max because it's the max integer size. But I don't know. Right now, the max integer size is a 64-bit integer. I think Rust at this time of recording does have support for like 128 bits integers, which is insane, I think. But, well, for now, I hope that 64 bits is enough. And it should be, considering how large the value can get. A 32-bit integer can store up to 4 gigabytes of address data if it was unsigned. 64 bits is not 32 bits times 2. 32 bits times 2 is 33 bits. So instead, it's like it's being multiplied by 2 32 more times, because the number of values a bit can take is 2 to the power of n, where n is the number of bits. So 2 to the 1 is 2, because it can be 0 or 1. So likewise, 32 bits is up to 4 gigabytes, and 64 bits is an astronomically large number. So I'll say it again, I hope that's enough to use, and it probably is enough to use for a long while. And testing once more. I think I do a little bit of stuff while it's testing, running. Taking its time there, but there definitely is a lot of files in my home folder, apparently. I guess here, yeah, printf. Thinking about adding a new line, because there are no new lines being printed during these progress percentages. Would make it cleaner if there's a new line after that. But if it never gets printed at all because it's fast from archiving a small number of files, there would be just like a random new line, but it's not that big of a deal. Ah, wall of text. Anyways. At this point, there is enough statistics for this previous pre-archival part. I'm basically done with the main features that I intended to implement. Adding new lines here just in case as well. Another commit for these changes. So I'm double checking the code again to see if there's anything I missed. And that one, that's a thing. I think I mentioned this earlier that I forgot to account for a time t variable to be passed to the pointer array at one point, and that spot is where it is. If I underallocate for the pointer array, there's risk of a buffer overflow if I write to a late entry in the array. That's how easy it is to get a buffer overflow, which is sad. Committing this fix. So at this point, all the changes I've done in the session are done, basically. I don't think I added a new commit yet, other than what I've done in this session. Anyways, this should make it a lot more responsive when archiving a huge amount of files. So that's basically it. So thanks for watching.